Hello everyone, in this video I'm going to explain you the problem in Sum of binary search tree. So basically they've given a root of the binary search tree and then they've given two integers, low and then high. So we have to find nodes which have a value greater than or equal to low. Here it is low, and then node with a value less than or equal to high. So we have to find those node and we have to sum up the values of the node, and then we have to return the answer. So let me take these two examples and explain what it is saying. So basically now they have given a root array, and then this array is of level order form, as you can see from the picture. And then array 10 is a root node and 10 has a child 5 and 15. So 10's child is 5 and then 15. Now 5's child is 3 and 7, so it is here 3 and then 7. Now 15's child is only 18, like left child is null, we don't have anything here, and then right child is 18. So in this way, like in level order form they've given, and then low value they've given as 7 and then high as 15. So basically we have to find the roots which have a value greater than or equal to 7 and then less than or equal to 15. So 10 as you can see, it lies in the range 7 and 15, so this value will be counted. And then 5, if you see, so it is less than 7, so it will not be counted, and 3 also not be counted, but 7 is counted because in question they have said it like inclusive, they have said inclusive of the range. 15 we can count, and then 18 we cannot count because it is greater than high. So actually if you sum up these three values, so 10 plus 15 25 plus 7 is 32. So this we have to return the answer. Let me take second example and then explain. So 10 is the root node and 10's child are 5 and then 15, as you can see from here. And then 5's childs are 7 and 3, so 5 child are 7, 3 and 7. And then 15's child are 13 and 18, so we are basically going in level order this way. So 15 child are 13 and then 18. Now 3's child is only 1, and right side it is null, we don't have anything, so 3's right child is null. And then 7's left child is 6, and then we don't have any child right and for this also, so they have left like they did not put anything, so it is implied it is null. And then low value is 6 and then high value is 18. So basically we have to find the nodes which have a value like greater than or equal to 6 and then less than or equal to 10. So as you can see, this can be counted, this cannot be counted because it is less than 6, this cannot be, and this cannot be, and this we can, this also we can, this cannot be, this cannot be, and this cannot be. So you have to return these three sum of values. So 10 plus 17 and then 6 is 23. So in this case we have to return 23, yeah, which is here. So one way of doing is that we will traverse through the root node, we'll go to the left child and check if the value lies in this range. If it is if it lies, then we have to return this value, and then we have to go to left side. So in this case, as you can see, 3 is not in the range, so we will not return, and we will move to the left. So left here is null, so in null we will return as 0, since null does not have any value, so it is treated as 0. Similarly, when we come back, we will move to the right side, and if value lies in the range, so we will return those value. So from here 7 will be returned, and from here only 7 will be returned, and we'll move to the right side. 15 is lying in the range, and we'll move to the left. Left has nothing, so it will return 0, and we'll move to the right. So right has 18, which does not lie in this range, and so we will return. We'll move to the left side basically. So left side is nothing there, so 0 will return. Right side also nothing is there, 0 will return. Since this does not lie in the range, we will add this left and right, and then we will simply return those, so which is 0 only. And in this case left is 0, right is also 0, but this value lies in the range, so we will return this value, left plus right plus, and this value, so 15. So 15, and then here this 10 also lies in the range, so 15 plus 7 will give us 22, and then plus that node value 10, root value, so which will sum up to 32. So let us write our function. Its return type is integer, and it will take root of the binary search tree, and then low value and then high value. So our base condition would be if root is null, which means there is no root. If root is null, so we can return 0, and we'll take one variable as answer, and we will initialize it to 0 first, and then we will check if the current value, like root of value, is greater than or equal to low, and same thing, this root of value less than equals to high. So if this is the case, then only we will add the current root value to the answer. So answer will write it plus equals to root of value, and then we will move to the left side, which is basically function root of left comma low comma high, and then we'll move to the right side also, and then we'll pass low value and then high value, and at last we will return this answer. So I think you got this algorithm. So let me write code according to this algorithm. So first what we have to do is we have to check if root is null. If it is null, then we have to simply return 0, and I was taking one variable answer, and if root of value is greater than equal to low, and also root of value is less than equal to high, in that case only we will add the current root value, and simply we will call this function left side on the left child. So root of left low high. Similarly we will call to the right on the right side, and then I'm going to return the answer. So let me write as capital null. Actually null is an ULL pointer, so that is the reason it was not running. Now let me submit the code. So it has accepted, but here problem is in this algorithm we are going every node, each and every node. So this can be avoided because since it is a binary search tree, so we know that the values from the root from the current node on the left side will have always lesser values, and the right side will have greater than or equal to values. So as you can see, this is a node so which has value 10, and left side if you see all has value lesser than 10, 5, 7, 3, and if you see right side it has more than 10 values, so 15 and 18. So like according to binary search property, we can avoid going to all the nodes, and what we have written code for that time complexity is O of n. Since we are visiting every node of the tree, so it is O of n being the number of nodes of the binary search tree. So as I said, like according to binary search tree, we can reduce this time complexity, or we can visit less number of nodes. Also, like low value is 7 and then high value is 15, so it has to lie in the range the node values. So this value is lying in the proper range, like 7 and 15, so we'll go to the left side. And if we go here, then we can see that this present value has lesser than low value. So according to binary search tree, so if you go any node to the left side, then that values will always be lesser than this value. So this what we are going presently can be avoided, because we don't need to go there, because every node whatever we will having, so that value will be always lesser than this value. So in that case we can go only right side. Also from here you can see we are going right side, and in this case we'll go both left and right. Let's say we have one more node here of value, let's say 15. So in that case what we will do is, since this value is 18, which is greater than a higher value, we will not go on right side, because according to binary search property, right side values are always greater than the present node value, greater than or equal to. So we'll move to the left side. So in that case this node will be counted. So basically in our code we have to put some conditions so that it will go according to condition, like we should go only left, we should go only right, or we can go both side. So for that condition what I'll be doing is, since if root is lying in the range of this range, then I'll move to both like left child and then right child. If the present value is lesser than the lower range, then in that case I'll move only right side. And if the present value is greater than the high value, so in that case I'll not move right side, I'll move only left side. So let me write code and show you. This condition is fine. If root is null, we have to return 0 and answer is 0. But here what I'll be doing is, I'm checking if root value, okay, if it is less than low, then in that case that node value will not be counted, but then we can move only right side. So we will be moving on the right side, and else if root of value is greater than high, so in that case we will move only left side. And if these are not the cases, which means like the present node lies in the range, so in that case we have to add that present root value to our answer, and then we'll move to the left side. As well as we'll move to the right side. So now let me run the code. So this is basically high. It is running. Now I'll submit the code. So in this case time complexity will be like lesser than O of n basically. In worst case it will be O of n, because if all the nodes lie in the range, like the values will lie in this range, all values, then in that case it is O of n, but in other cases it will be lesser than O of n. So I think you got the problem and the solution. So thank you for watching.